Alright, this is your follow-up podcast. It's called Naming Ionic Compounds. So we just did formulas, and now we're going to do names. At the end of this, there's going to be a slide that has 5 examples for you, so hopefully you're taking notes as you go along, but those 5 examples at the end you're going to need to show me just to kind of make sure everything's going alright, and then you're going to trade me for your assignment at the end of that. So this should look familiar, your periodic table that we've marked on. Your cations have a positive charge, they're your metals. Your anions are your nonmetals, they have a negative charge. Remember, these guys in the middle, these transition metals, and then these group 4 metals right here can have multiple charges. And if you look on your common ion charges sheet, it's a salmon colored sheet that I gave you in class. It's going to have all of these metals listed and all their possible charges. Okay? You're going to want to have that handy. On the back of it is also a list of your polyatomic ions in case you forget some of them. When we write the names, we're going to write the cations first. Cations are the positive ions, and they're going to keep their name. Anions go second, and we're going to change the ending to IDE. So for example, chlorine will become chloride. If you have a polyatomic ion, so those are the extensive list on the back of your common ion charges sheet, the endings are going to stay the same. You've been taking some polyatomic ion quizzes, and so we've been doing that so that you recognize these names whenever you see them. Okay, and then if your cation is a group 4 or transition metal, you gotta put the charge as a Roman numeral, because remember, these can have a lot of different charges, so we want to make sure that people know what we're talking about. So we're going to start with a simple one, and that is NaBr. Na is sodium. It's just a regular old metal, it's not a transition metal. And then Br is bromine. We're going to change bromine to bromide. So this is sodium bromide. Okay? SrF2. Sr is strontium, and F is fluorine. So strontium keeps its name. Fluorine changes to fluoride. Remember, if at any time, if I'm going too fast, feel free to pause, rewind, and listen to these again. So FeO. Fe is iron, and iron is one of our transition metals. So iron has 2 possible charges that it can have, a +2 or a +3. And how do we pick? Well, we're actually going to look at the charge of oxygen. Oxygen has a -2 charge, and since we know that ionic bonds have to be electrically neutral, so the positives and negatives have to cancel, we're going to pick the charge for iron that's going to match oxygen's charge. So we're going to pick the +2 option. So to tell people that this is iron with a +2 charge, we're going to put it in parentheses as a Roman numeral behind iron. So how I would read this name is iron 2 oxide. I'm going to read those Roman numerals just like numbers. Okay? Well, iron has multiple charges, so it can make different kinds of compounds with oxygen. So here's another example of iron and oxygen bonded together. Iron still has the same options, +2 and +3. But if you notice, there's a 3 back here behind the oxygen, and that 3 got there by crossing the charges. So remember in our last PowerPoint, we would have started with Fe +3, and then that +3 would have transferred down or crossed over to the oxygen. So because of that, we know if we can uncross the charges, we can put it back where it started from originally. And we're going to pick iron with a +3 option. So we would say iron 3 oxide. Okay, LiNO3. Li is lithium. NO3 is a polyatomic ion called nitrate. You'll notice there are 3 capital letters, and anytime you see 3 capital letters or 4 capital letters or multiple, more than 2 capital letters, you need to be on the lookout for those polyatomic ions. Okay? So it may have seemed mean to make you memorize them, but this is why, so that whenever we see them, we're going to recognize them in a compound. So lithium nitrate would be the name of this. Now, it's tempting to write lithium nitrogen oxide, but that's not correct because it's not nitrogen oxide. That nitrate ion stays together. So if you find yourself writing 3 words or more than 3 words, then you've missed one of these polyatomic ions and you need to go back and look for it. So that's something you need to get in the habit of. If you start writing a third word, you need to stop what you're doing and go back and look for a polyatomic ion. Okay? So sometimes our polyatomic ions end up in parentheses, and that makes them a little bit easier to see. So in this case we have Mg, that's magnesium, and we have OH, which is hydroxide. So this is going to be magnesium hydroxide. Cu, C2, H3, O2. So I have 4 capital letters in here, which means there's a polyatomic ion. Do you see it? It's right here, and its name is acetate. Okay? So acetate is our polyatomic ion, but if you'll notice at the beginning we have copper, and copper is one of our transition metals. Well, copper can be a +1 or a +2. And it may be really tempting to uncross this 2, but you can't, because this 2 didn't get here by crossing the charges. This 2 came here because it was part of the acetate ion. So I'm going to look at the charge of the whole acetate ion, and that happens to be a -1. So I'm going to pick the charge of copper that's going to cancel with that, and that's the +1. So I would say this as copper 1 acetate. Well, copper is a +1 or a +2, and so here we're bonding it with sulfate. Well, sulfate has a -2 charge. So because sulfate has a -2 charge, that's where I'm going to start. But do you notice that there's a little subscript here behind copper? That means I have 2 copper ions. So I'm going to take my charge of sulfur, or sulfate, I'm going to have to divide it by 2 because that's my subscript. And then that's what I'm going to have to use. So -2 divided by 2 would be 1, so that means that each of these coppers has to be a +1 in order for everything to cancel. Okay. I know these can get a little confusing when you have the transition metals and the polyatomic ions together, so if you need to stop, you need to ask questions, you need to go back and listen to these again, please feel free. This is why we're doing it this way, so you can go at your own pace. FePO4. So Fe is iron. Iron has multiple options. Remember, it can be a +2 or a +3. And then phosphate is one of our polyatomic ions, that PO4. So I'm going to look at the charge of phosphate. It's a -3, so I'm going to pick iron as a +3 in order to cancel with that. So iron 3 phosphate would be the name of this. Okay, so these are 5 examples, and these are 5 tricky examples. So I'm going to have you pause your podcast. I want you to take your paper and write down these 5 examples. If I give you the name, like in numbers 1, 2, and 3, then I want you to write a formula, like that was what you did in the first podcast. In 4 and 5, I give you a formula, and I want you to write the name, which is what we talked about in this podcast. So I want you to pause, I want you to practice, and then I want you to check. Okay, so here we go, checking our answers. Beryllium hydroxide. Beryllium is Be+2. Hydroxide is OH-1. It's one of those polyatomic ions, and it's one of the ones that doesn't end in ATE or ITE, so it's sometimes hard to find. Silver sulfate. Silver is always a +1, and sulfate is SO4-2. So I'm going to have to cross the charges, Ag2, SO4, but I don't have to write the 1 behind sulfate, so I don't have to put parentheses there. Tin 4 oxide is going to end up being SnO2. You may have had SN2O4, but remember that you have to put these in lowest terms. FeCO3, iron can be a +2 or a +3, because carbonate is a -2. It's going to be iron 2 carbonate. And then Mg3PO42 is going to be magnesium phosphate. So I hope this helped. Feel free to ask questions if you need to.